Alright, this is chapter 6, problem 48. It says, an ingenious bricklayer builds a device for shooting bricks up to the top of the wall where he is working. He places a brick on a vertical compressed spring with force constant K equals 450 newtons per meter, and negligible mass. When the spring is released, the brick is propelled upward. If the spring has a mass 1.8 kilograms, and is to reach maximum height of 3.6 meters above its initial position on the compressed spring, what distance must the bricklayer compress the spring initially? So a few equations we're going to have to start with to manipulate. We're going to start with our work energy theorem. Kinetic energy equals, so work equals delta K, or change in kinetic energy. And we will also but we're going to need to know the difference in our potential energies is going to be 0. So that would mean that the potential energy of the spring is equal to the potential energy of gravity. So it has the same potential energy here as it does here. See, now we can set U of S, so our potential energy in the spring equal to work, which then equals 1/2 kx squared. Our question, what we're looking for is how far it needs to compress the spring. That is our x. So we're going to do a few more things before we solve for that x. We're going to set U of g equal to mgh. So we have our spring potential energy, which we can set equal to this, our gravity, which we can set equal to that, and because here we decided that those were equal, we can then set those equal to each other. So then we have mgh equals 1/2 kx squared. Now, like I said, we can solve for x, which is the distance we need to compress the spring. That would give you x equals square root of 2 times mgh over k. So I do have that correctly. And now we can plug and chug. It's pretty great, pretty easy. So for K, we have 450 newtons. For K, the spring constant, I believe. 1.8 for M. Then 9.81. And our height should be 3.6. And when we add in all of our values into my calculator, we got, let's see, here we go. It was 0.53 meters. So you need to compress the spring 0.53 meters in order for it to launch 3.6 in the air. Now there was a second part to this question. It says, the brick loses contact with the spring when the spring returns to its uncompressed length. Why is that? My explanation would be, you have your spring here. When it's compressed, it's pushing this way. When it's uncompressing, which is then pushing your brick, this force is acting on your brick. But once it is fully stretched out, this force goes away, comes like that, but your brick's still moving away. So the spring is pushing on the brick. Once it gets to its point where it's no longer compressed, it stops, but your brick has momentum and it keeps going. So that was question 48 in chapter 6.